ladies and gentlemen, and welcome to the Future of AWG webcast. I would now like to turn the webcast over to Mark Bagdy.
Well, good morning or good afternoon, wherever you may be located. Agilent warmly welcomes you and thank you for joining us today for this webcast entitled See the Future of Arbitrary Waveform Generators, brought to you by Agilent Technologies. My name is Mark Bagdy. I'm a program manager with Agilent Technologies. I will be your host today. You have three presenters, and they're all with Agilent Technologies, and they will be first, Ron Nersessian, President of the Electronic Measurements Group, or EMG, Jürgen Beck, General Manager of Digital Photonic Test, and finally, Bob Jewett, Principal Project Engineer of EMG's Measurement Research Lab. Also on the phone to help answer and manage questions after the presentation is Michael May, Project Manager for Arbitrary Waveform and Pulse Pattern Generator Products, also with Agilent Technologies. In today's webcast, Ron, Jürgen, and Bob are announcing a new breakthrough technology for the next generation of arbitrary waveform generators. We're listening to our customers and then using our technology leadership to deliver capabilities that no one else currently provides. Agilent Technologies has now expanded into a new market segment with our new high-speed arbitrary waveform generators. Over the next hour, you will learn how Agilent can help you push your design to the limit and bring new insights into your analysis. The impossible, you might say, now becomes possible: wide bandwidth and high resolution. Those of you attending today are about to find out how. We'll begin today's webcast in just a moment, but first, a few administrative information points about our tool. Webcast today is using WebEx Event Center. It allows you to just sit back and have the presentation slides just navigate automatically and advance automatically. To participate, though, in the Q&A session, please type your questions at any time during the presentation in the chat window directly to all panelists. Questions will be answered at the end of the webcast, but again, please feel free to type them at any time. If we are unable to answer all the questions in time, one of our experts will follow up after the webcast with answers via email. Finally, we ask that you take a moment to please fill out the short feedback form that will appear when you close the WebEx session. And now, I will turn the floor over to our first presenter, Ron Nersessian. Welcome, Ron.
Welcome to the Future of Arbitrary Waveform Generators. I am Ron Nersessian, and I'm delighted to be here today to tell you about a brand new breakthrough from Agilent that allows you to get the widest bandwidth and the highest resolution simultaneously for your toughest measurement challenges. Agilent's new arbitrary waveform generator utilizes in-house technology developed in Agilent labs that delivers the first software switchable 12 gigasample per second 12-bit and 8 gigasample per second 14-bit arbitrary waveform generator. With this breakthrough in technology, we can meet market requirements today and tomorrow. The 5 gigahertz bandwidth gives you enough headroom for today and the next generation of devices. It lets you create signal scenarios that push your designs to the limit and bring new insights into your analysis. The new arbitrary waveform generator is by far the highest performing arbitrary waveform generator in the market today. It offers 80 dB in dynamic range, a 30 dB advantage over its closest competitor. It also has 30 times deeper memory than any other product in the market, with up to 1/6 of a second with 2 gigasamples of memory per channel. The fact that it is software switchable allows you to optimize performance for the speed and resolution required by your application. Those of you working in aerospace and defense, in the communications or computer industry, need products to generate real-world signal scenarios. This arbitrary waveform generator is the only product that generates unmatched signal purity at the highest frequencies you utilize. At Agilent Technologies, we are committed to providing you the most value we can by leading the market with test and measurement technology. We use our technology leadership to develop capabilities that no one else in the industry can. We continuously monitor technology trends such as the increase in device complexity, the increase in data rates, the trend for smaller and less power-consuming devices, and the never-ending increase in test efficiency. And we invest in the research and development of new classes of instruments to address those needs. In this case, your next-generation technologies call for instruments with the best signal purity at the fastest speeds. Other commercially available products can deliver either signal purity or signal speed, but not both. With this arbitrary waveform generator, you no longer have to compromise. The new AWG is the result of collaboration between Agilent Labs and high-speed digital research teams following the same development model used with another recent product breakthrough, the new 32 gigahertz Infinium 90,000 X series oscilloscopes. It uses a disruptive technology achieved through a BiCMOS silicon germanium process that is 3 years ahead of the market. We are bringing the AWG to you using the newly introduced AXI platform that Agilent Technologies, Aeroflex, and Test Evolution created in 2009. This is an open-based standard platform based on advanced TCA, or ATCA, that creates a robust ecosystem of components, products, and systems for general-purpose instrumentation and semiconductor test. It's a great example of how we're able to bring leading technology to the market and to you faster in a modular form factor. It also fits very well with Agilent's arbitrary waveform generator portfolio. Agilent offers products with 1 gigahertz modulation bandwidth and 15 bits of vertical resolution and the best signal quality in the market. In 2010, we launched a 12-bit 4.2 gigasample per second AWG. Its 2 gigahertz of modulation bandwidth, which is a great fit for many applications, is often used as a modulation source with Agilent's performance signal generator for up conversion. With the new addition, Agilent has entered the high-speed arbitrary waveform generator area. You will achieve the same signal quality as our high-resolution offering, but with a much higher sample rate. The end result is not having to compromise between bandwidth and resolution. At this point, I'd like to turn the presentation over to Jürgen Beck, the General Manager of our Digital and Photonic Test Division. He will get a chance to take you through the details. Thank you very much for joining us today.
Thank you, Ron, and hello, everybody. I'm Jürgen Beck, and I'm today pleased to introduce to you our new high-speed M8190A arbitrary waveform generator. But before we go to the product, let's take a look at the target markets and key applications. First, radar and electronic warfare. Reduced size and power requirements call for digital radar. There is a need for higher resolution to discriminate close-in targets and low-level signals, and users need to simulate with the most realistic signals to avoid expensive live tests. Also, playtime is a key topic in that space. Secondly, satellite and wireless communication test. High data rates, less signal uncertainty, and interoperability are critical. To cram more information into existing bandwidth, digital modulation is the way to go. But the higher number of digital modulations tend to get into inaccurate signal levels, and phase angles are causing fading and other issues. Third, serial bus standards. Customers want to generate multi-level signals and programmable inter-symbol interference and jitter. new levels of distortions are coming up, and users have to flexibly adopt these new requirements. They want to mimic analog imperfections as easily as possible. Components like analog to digital converters get into higher data rates, but the high-end components need adequate test instrumentation as well. And finally, there are a number of general-purpose applications. Any investment should meet today's and also tomorrow's requirements. Our customers need to keep their programs on spec, on budget, and on time. They want to be confident that they test the design and not the source. Measurement needs to be reliable and repeatable, and nobody wants to interpret glitches as analog output and avoid undefined variations. All these applications call for a new high-resolution arbitrary waveform generators at high bandwidth. The new M8190A delivers the highest signal quality with a much greater dynamic range compared to what's available on the market today. Today's offers are no better than 50 dB, while Agilent offers 80 dB, which is a 30 dB advantage. The unique performance results in unique value to our customers. The general idea of this new product is to enhance the test reality of the application. We do this by providing a source of greater signal fidelity, delivering high resolution and wide bandwidths simultaneously. Agilent's new arbitrary waveform generator is based on Agilent's own digital to analog converter technology. The DUC provides a resolution switchable between 14-bit and 12-bit. The fact that it's software switchable allows customers to optimize the AWG's performance for speed and resolution depending on their test applications. This is delivered at the highest signal quality with a much greater dynamic range compared to what's available on the market right now. Our competition is to rely on a standard DUC technology providing 10-bit vertical resolution, and if markers are used, the number of available bits is further reduced down to 8. The mathematics are very simple. The rule of thumb says that 1 bit is good for 6 dB in dynamic range. So let's focus on the technology. I will now hand over to Bob Jewett, who worked on this new technology.
Thank you, Jürgen. I'm Bob Jewett, one of the engineers at Agilent Research Labs who developed the chip that's at the heart of the M8190A. Let's look at two approaches for generating modulated signals at RF and microwave carrier frequencies. On the next page, we'll see in the top screenshot, the traditional method uses relatively low bandwidth DACs to drive an IQ modulator to translate the baseband up to the carrier frequency. In the example shown, the signal is a simple two-tone test, and as you can see, there are lots of spurious tones along with the two intended tones. It's difficult to keep a system like this aligned to have better than 50 dB C spurious. In the lower screenshot is a similar signal generated directly using Agilent's new DAC technology. Because the DAC is very linear, the spurs are low, and because the DAC is very fast, the signal can be either at the final microwave frequency or at a very high IF frequency that is easy to mix up to much higher carrier frequencies. The key to this technology is shown in the next two slides. The waveform on the left illustrates a problem that all high-speed DACs have. As the input data steps from one digital value to the next, the output voltage doesn't step perfectly, but instead has unwanted transient glitches. If allowed to get to the output, these glitches would appear as spurious signals. A standard technique to fix this problem is shown here. You use a resampling switch which connects the DAC signal to the output signal only after the transients have settled out for each data value. The result is a much cleaner signal as shown on the right. Our remaining problem is also shown on the right. The switch must pass the entire range of output signals, and it is difficult to make a switch that is both fast and linear. Often the result is that the switch will cause distortion. In the waveform, the upper step is somewhat attenuated compared to the first step. Actually, the difference is greatly exaggerated. A difference of just 0.1% in the step heights corresponds to a spurious level of about 60 dBc. On the next slide, we show our patented solution to this, which is called distributed resampling. The DAC is composed of multiple identical current sources, and each one is given its own resampling switch. So each current is either on or off in that part of the DAC with no intermediate values through any switch. These identical currents are then added together in an output termination resistor, which is a very linear way to combine currents. Very low jitter is achieved by using a very clean clock source to do the resampling. The output jitter is mostly determined by the clean clock rather than by the timing of internal latch delays and other high jitter mechanisms. Careful design of the individual current sources ensures excellent matching, which is also required to achieve very low spurious levels. Agilent's proprietary technology has given us a large advantage over commercially available DACs, which are still very far from this speed at this linearity. Now I'll hand back to Jürgen.
Thanks, Bob. But besides waveform resolution and wide bandwidth, we also detected play time as important. Our new AWG provides a memory depth of 2 gigasamples, which results in a 1/6 of a second play time at the highest sampling rate. You never have enough memory, so it's important to have different levels to build up complex waveforms. Different levels ensure that it's possible to set up complex playback scenarios through sequencing and looping techniques, which are briefly described here, with up to 256K segments and up to 4 billion loops per segment. It's possible to initiate a communication between a ground station and airborne, or to simulate flight scenarios of an airborne with this kind of a setup. The real-time memory access ensures also that the play scenarios can be adapted to new upcoming needs immediately. New situations can be reflected as soon as they occur. Different applications require different signal characteristics. Customers are often looking for a versatile instrument to cover all the different use models they need. Our new AWG provides 3 selectable output amplifiers. The first one is optimized for the IQ applications. Important here is differential DC-coupled signals and spurious-free dynamic range and harmonic distortion values are very important as well. The next application focus is our direct RF applications. The amplifier for this is single-ended and AC-coupled. Flatness is one of the key specifications in this area. And last but not least, time domain applications require low jitter, low overshoot, which is addressed by the third amplifier you see on this chart. Signals are differential and DC coupled with a variable amplitude. The output voltage window is between -1 volt and +3 volts. The 3 different amplifiers ensure best signal quality, allowing to test with confidence and without compromises. This mentioned functionality is a perfect fit for the applications which I've outlined earlier. Aerospace and defense with radar and electronic warfare, communications with satellite and the new IEEE standards, serial bus standards, as well as general purpose and education and research. We will dive now into the different applications in a little bit more detail. The arbitrary waveform generator is the ideal instrument for the engineers who are working on products for aerospace and defense markets such as radar. With 2 gigasample of memory and up to 5 gigahertz of analog bandwidth, customers can generate realistic waveforms that maximize the need for high-cost flight testing. It lets you create signal scenarios that push their designs to the limit and bring new insights into their analysis. A typical measurement in radar applications is the linear frequency modulation chirp, or LFM. In the measurement on the upper right corner, you see the chirps spanning 2 gigahertz, and the linearity is just outstanding. The flatness shown in the time domain and in the frequency domain is possible because of the 14-bit resolution. All customers testing satellite communication systems require outstanding signal quality. For example, customers who emulate transmission from ground station to an airborne transceiver and back to distant ground stations, they will benefit from the industry-leading spurious-free dynamic range, which is enabled by the 14-bit resolution. It lets the tones clearly stand out from the noise, even with thousands of tones being present. The multi-tone measurement is a typical measurement for satellites. In this example, you see 100 tones from 0 to 3 gigahertz with a spurious-free dynamic range of 59 dB. Our competitors don't achieve this even with 1 tone. A multi-tone measurement is used in many other applications. One additional example here in this space is analog to digital converter testing. Higher level modulations are also very important in the communication applications. Here you see the constellation diagram on the left side of the screenshot. The error vector magnitude is the important number on this analysis screen. The EVM of the test setup is below 1%. You need such a low number to ensure that the EVM of your design under test doesn't hide behind the EVM of the source that is stimulating it. Otherwise, you would test the source and not the design as intended. The very low error vector magnitude makes the arbitrary waveform generator a perfect instrument for testing wideband wireless applications. The modular form factor of the instrument reduces system size, weight, and footprint, and also allows future expandability. Serial bus standards, applications needing multi-level signals, and programmable inter-symbol interference and jitter are other key applications of an AWG. You just need to find the mathematical description of your analog imperfection, and you can easily mimic them precisely. On the left side of this slide, you see an ideal signal. Based on a MATLAB script, which is shown in the middle, you can add sinusoidal jitter, random jitter, or ISI, or other distortions. Just download the waveform and you have simulated any analog imperfection that occur in real-world signals. You find the MATLAB script as an example on our web pages. Frequency hopping is also a very common application. Secure communications rely on that. With an unknown pattern hopping between the frequencies, unauthorized listening in the data transfer becomes very difficult or almost impossible. The example here shows 21 tones spanning 2 gigahertz. The instrument has a switching time of less than 15 nanoseconds. The 5 gigahertz analog bandwidth gives enough headroom for the future. Depending on the application needs, we see two different setups. Either to generate the IQ signal with the 2 available channels and use an up converter to load it on higher frequency carriers, as it is shown in the upper part of this picture. In this example, it uses an Agilent E8267D precision signal generator up to 44 gigahertz. Or, as it's shown at the bottom of the chart, generate the IF or RF or the digital signal directly. This picture shows different configurations enabled by the modular platform. The M8190A is available in a 5-slot or in a 2-slot AXI chassis. The 5-slot chassis can integrate an embedded PC. You just have to connect the monitor and a keyboard and you are coming close to a box. AXI is the new instrumentation standard based on the advanced TCA with an extension for instrumentation and test. The AXI standard was publicly announced November 10th in 2009, and the specification was ratified in June 30th, 2010. With the software support, you can maximize the benefits of the market-leading hardware design. For generating signal waveforms for Agilent's AWGs, there is a variety of software applications available. The most flexibility is certainly offered by applications such as MATLAB or LabVIEW, or the development of your own signal calculation software, for example, using Microsoft Visual Studio. Access to the AWG is through the SCIDI programming commands, or somewhat more comfortable through function calls of the supplied IVI driver. Examples are available for all of these programming environments so that the integration into an existing environment is made really simple. I would like to particularly point out MATLAB at this point, since it's very well suited to calculate, manipulate, and display complex signal waveforms, which can be downloaded to Agilent's AWGs. All the examples shown throughout this presentation have been generated using MATLAB scripts or little MATLAB graphical user interfaces. These are available for free from the Agilent website. The BenchLink waveform editor, shown on the top right, allows you to set up and download simple waveforms in a graphical display. On the bottom right, we have the Agilent Wideband Waveform Creator software, an application that has been developed specifically to generate wideband wireless HD and IEEE 802.11 AD and AC signals. Next, we have Signal Studio Pulse Builder and Multitone. These are two well-established applications that are often used with Agilent signal generators to generate pulsed radar signals, respectively multitone signals. These applications are optimized to remove any distortions in the signal path. Agilent SystemVue, a leading model-based design automation tool for communications physical layer design, now links with Agilent's next generation of high-performance AWG products, accelerating design to test for complex wideband and wide dynamic range systems. SystemVue provides the packaged applications know-how and waveform expertise to drive Agilent's high-performance AWG products with fully customizable waveforms to both proprietary and commercial standards. Applications supported in SystemVue include ultra-wideband radar and digital array beamforming radar, ultra-wideband wireless PAN standards for 802.11 AC and AD, 8x8 MIMO waveforms for 4G, and fully customizable wideband OFDM useful for wideband networking waveforms. SystemVue measurement automation capability allows flexible test scenarios to be created, marrying next-generation AWG products with other Agile and wideband signal analysis and data acquisition products to form a unique measurement automation test solution for 4G, electronic warfare, radar, SATCOM, and broadband networking applications. The M8190A enhances your reality because it's a source of greater fidelity, delivering high resolution and wide bandwidth simultaneously. The 14-bit gets you up to 80 dBc SFDR, which is 30 dB better than the closest competitors. Tones will clearly stand out of the noise, even with thousands of tones. The 2 gig sample memory allows you to build realistic signal scenarios. A 1/6 of a second play time is 30 times more than what's available from the competition today. Any kind of analog imperfections can be generated by a mathematical description. No hardware is needed in addition to emulate ISI, for example. This unique combination lets you create signal scenarios that push your designs to the limit. Get bits and bytes, and bandwidths, and enhance the reality. Agilent will continue to invest in arbitrary waveform and arbitrary function generators, as well as in other test and measurement products and technologies to bring you the world's leading products. Thank you for partnering with us for many years to come. Ladies and gentlemen, this concludes the presentation for today. I hand over back to Mark for Q&A.
Well, thank you very much to Ron, Jürgen, and Bob. We appreciate very much your information. So before we begin today's question and answer session, please note the URL on this slide for further information. I'd also like to take this time to remind you about the survey. Agilent holds many free webcasts throughout the year, and all we ask is that you take a couple of minutes to complete the survey that will appear when you close the WebEx session. That valuable information that you submit will help us to improve these webcasts in the future. So let's begin the Q&A session. And again, you can continue submitting questions during the Q&A part to our presenters. Simply type in the chat window. Looks like many of you have been sending in some questions already, and submit them to the panelists. Looks like, Jürgen, our first few questions are for you, and I'm just going to dump the first two questions right into you since they kind of go together. How much are the instruments, and when will we start shipping them?
All right, thanks for the question. The price point is starting at $76K. The 76K contains one channel with 14-bit and the 2-slot AXI chassis. The 2 channels and 14-bit goes for $86K. To the next question, when will the product ship? The first configuration ships by the end of April this year.
Thank you, Jürgen. You commented briefly on the AXI chassis there. One of the questions, if there's anything further you want to add, the next question is where do I get an AXI chassis?
You can get it from Agilent. Agilent is offering 2 types of chassis as now, a 2-slot chassis and a 5-slot chassis, pretty much in the configurations that I've shown on the slide.
Thank you, Jürgen. The next question we have also is directed to you. One of the question is you mentioned switchable, You mentioned switchable performance, 14-bit 8 gig samples per second, and 12-bit, and so 12-bit combined with 14-bit. So what does switchable mean?
The products are going with 2 options, one for the 14-bit 8 gig sample and the 12-bit 12 gig sample sampling rate. So customer can pick and choose the values they need, either just decide for one option or go with both options so that you can pay only what you need.
Very good. Thank you, Jürgen. Another question is, can you point us to the MATLAB scripts for generating the user-defined jitter?
Yeah, the scripts are available on the Agilent web page, and the URL is www.agilent.com/find/81180 examples.
Thank you very much. Another question, looks like for Jürgen also, is what were the 3 separate amplifier stages? IQ was one of them, but what were the other 2? That was for you, Jürgen, sorry.
All right, I'm sorry. Okay, so we have 3 selectable output amplifiers. The first one is for IQ applications. This is differential DC coupled signals and optimized for SFDR and harmonic distortion. The next one is direct RF. The amplifier for this is a single-ended AC coupled amplifier with optimized on flatness. And the last one, the third one, is really targeted towards time domain applications, which is optimized for low jitter and low overshoot. And that's, as I said, targeted to address time domain applications. And the output voltage is between -1 and +3 volts.
Thank you, Jürgen. Next question is for you also. The software, will it sell separately or does it come free with the equipment? And if it is sold separately, does it have a price tag? You, Jürgen?
There are a couple of software packages available from Agilent. They are selling as individual products and have a price tag. So I suggest to consult with the Agilent web page to get more information on those software packages. So, for example, SystemVue is a very large and very powerful application package. Also, Agilent Signal Studio is a large application package that is selling as a separate product.
Excellent. How often is calibration needed, and does it need to go back to the factory or to Agilent for calibration, Jürgen?
Yeah, typically the calibration is provided by an Agilent service center, which is available and distributed around the world. We have a calibration cycle of 1 year, so with 1 year calibration coming from Agilent, we guarantee the performance that we've shown.
Very good. Next question, Jürgen, for you too, is I assume the output of -1 volt to +3 volts is into 50 ohms. Comment?
Yeah, that's absolutely correct. It's in a 50 ohm -1 to +3 into 50 ohms is correct.
Very good. Does Agilent have a solution to up-convert the M8190A IF output? And again, Jürgen, for you.
Yeah, one example is what I've shown. And there is also the E8257D option H30. This is an up converter, and I've shown an example here, which is an up converter for the 44 megahertz, for the 44 gigahertz application. In just looking for the product number here. That's the A8267D option 016. That's a precision signal generator coming from Agilent, and it goes all the way up to 44 gigahertz.
Thank you. Last question that I see in chat so far is, will these products be available in a small OEM package with computer control? And the requester is thinking about radar and electronic warfare system applications. Jürgen?
I'm not exactly sure if I understand the question correctly. So OEM package meaning that customers can OEM the products from us and integrate it into their applications. If that was the question, I think you know, we are following all kinds of business models with our products in general. It depends on what really the application requirement and also the business model is, but we are ready to talk to our customers about those kinds of business models and partnerships. And so it depends on the individual requirements. So in general, the answer is yes, it's available, and we need to define the setup and the OEM requirements that are really, you know, driven by the customer's application in this case.
Thank you very much. And to the author of that question, if that didn't address it particularly, feel free to submit again. Another question, Jürgen, is the time domain output amplifier single-ended or differential?
It's a differential output on the time domain amplifier.
Thank you very much. So do we have any more questions that are in the chat box? Looks like we've looks like we've got another one coming in. Yes, for you, Jürgen, are all outputs available in a single instrument?
Does that refer to the 3 amplifiers?
The question doesn't say, so
I would assume that I would assume the question is referring to the 3 different output amplifiers, and if that's the question, the answer is yes. They are available in a single instrument, and they can be switched on and off by software, so they can be switched by software from one to the other output stage.
Very good, thank you. I see no more questions at this point. Did we want to just remind folks of the further information can be found on the URL that you see on your screen. And also, if you have any questions, feel free to type them into chat. Remember that your questions that you ask right now are going to be not only answered here, but will be available if, and especially if they can't be answered directly right here, we will have our experts afterwards follow up through email. We do have another question. Jürgen, for you. Whoops. There we go. Can multiple units be connected for greater than 2-channel synchronous generation?
Yes, that's possible. In a 5-slot chassis, for example, you can plug in two 2-channel AWGs that can be synchronized up to a 4-channel setup.
Excellent.
And I think I've shown this on one of the slides here in a 5-slot chassis configuration. That provides also, since it's a 5-slot chassis, it provides an extra slot for a system controller module, which is essentially an embedded PC that can control the software applications running on the configuration.
Thank you very much, Jürgen. I'm seeing another question come in. Is there an API for programming waveforms and for reading the sample memory with a custom application? Jürgen, can you comment on an API for programming waveforms and for reading sample memory?
Yeah, there is the Skippy programming interface is available that can be used for that purpose.
Okay, very good. Thank you very much, Jürgen. I see another question, more technical, so I think we'll pass this one on to Michael. Michael, what is the response variability to an external trigger from one output waveform to the next? Is it plus or minus one sample round?
So if the instrument is being clocked synchronously by an external clock, then it's accurate down to one sample point or even less. So there is no inaccuracy, basically.
Thank you very much, Michael. I think there's another question for you. What is the phase noise with respect to carrier offset?
So at a sample rate of 12 gigasamples, and let's say on F output frequency that is generated around 1 gigahertz, and at 10 kilohertz offset, the phase noise from an internal generated clock will be minus 85 dBc. And of course, if the instrument is being externally clocked, then one can see the phaseness of the external clock, which can be much better.
Thank you very much, Michael. I think I see an additional question, I think for Jürgen. I noticed the Agilent Wideband Waveform Creator in the slides. Do you provide this on the website, or does it have to be purchased separately? And if it's purchased, what's the product or part number for that?
Yeah, that's a product that can be purchased separately. The product number is something you would have to follow up on. I don't know this from the top of my head, but I would suggest that the person who has asked that question would send us an email, and we will respond to that with the product number.
Excellent, thank you. Is the output bandwidth programmable, Jürgen?
Yes.
Thanks. I think another question for Jürgen. For real-time operation, how fast can you change the waveforms generated, and how fast can we load them?
The switching is below 50 nanoseconds, but this is requiring the fast switching option. So there is a special option that provides that capability. There are also legal restrictions that we have to observe, for that capability.
Very good. Looks like another question coming in. Jürgen, what is the standard memory configuration?
It's 128 megasample.
Very good, standard.
That's the standard configuration. It has memory options for up to 2 gigasample.
Excellent, thank you. Any further questions from our looks like another question coming in. Question for you, Jürgen, again. In the eye simulation for broadband signals, in MATLAB, does this generate all the pattern combinations?
Yes, that can all be done in MATLAB. It's completely covered.
Great. Okay, very good. This will end the question and answer session right now. I want to, first of all, thank all for attending today. That's all the time we have for questions. On behalf of all the presenters, I'd like to thank everyone for attending the webcast, See the Future of Arbitrary Waveform Generators, brought to you by Agilent Technologies. A key point to keep in mind is that this presentation will be available shortly in an on-demand format, and that will be emailed to you directly. Keep in mind that that URL link for the on-demand version will be different than the one you used today to attend the live webcast. You will not be able to view the on-demand version using today's link. I'd also like to remind you to kindly fill out and submit your webcast survey. Thank you very much for joining us today, and have a great day.